Hello and welcome to DynaLearn. This video is about understanding feedback. It provides a number of examples of positive and negative feedback loops which become possible to develop from Learning Space 4 onward. Feedback loops are essential to understand the behavior of systems. The learning goal of this video is identify feedback loops governing a system. So what is a feedback loop? A feedback loop is a situation in which the effect of a process through propagation will affect this same process. In DynaLearn, a feedback loop consists of an influence and one or more proportionalities looping back to the original influencing quantity. So let's start with a positive feedback loop. A positive feedback loop strengthens the change that was caused by a process. The causal relations in a positive feedback loop have a net positive effect. For example, if you have a positive influence between quantity 1 and quantity 2, and a positive proportionality from quantity 2 back to quantity 1, then because these two causal relations are positive, the net effect will also be positive. In the second example, there's a negative influence from quantity 1 to quantity 2, and a negative proportionality from quantity 2 back to quantity 1. And because both these causal relations are negative, there will again be a net positive effect on quantity 1. And finally, in example 3, there's a positive influence from quantity 1 to quantity 2, a negative proportionality from quantity 2 to quantity 3, and another negative proportionality from quantity 3 back to quantity 1. Because we have one positive and two negative causal relations, the net effect will again be positive. You can see that the feedback loops in these examples strengthen the change that is caused by the process. Let's look at the first example. If quantity 1 is above 0, then the positive influence to quantity 2 will make quantity 2 increase. The proportionality from quantity 2 will propagate this increase back to quantity 1. So therefore quantity 1 will further increase. It will become more positive, so therefore its positive effect will become even larger. Now consider that quantity 1 is below 0. As a result, quantity 2 will decrease. And because of the positive proportionality between quantity 2 and quantity 1 will further decrease. Therefore, it will become more negative and the negative effect on quantity 2 will become even larger. So let's look at some examples of positive feedback loops. In this first example of a positive feedback loop, we see a population which has a size, which represents the number of individuals within the population. It also has a natality, which represents the number of individuals that are born. There is a positive influence from the natality to the size of the population, because the individuals that are born add to the size of the population. There is also a positive proportionality from the size to the natality, because if the size of the population is bigger, more individuals will be born. Because these two causal relations are positive, this is a positive feedback loop. And the process within this loop, namely natality, will become stronger because of this loop. This second example of a positive feedback loop is about the melting of the ice that covers the Earth. The albedo, which is the reflection potential of the Earth, plays an important role. The loop consists of the following causal relations. The melting has a negative influence on the cover of the ice. If the cover of the ice increases, the reflection potential of the Earth will also increase. And if it decreases, the albedo will also decrease. If the albedo increases, then the greenhouse effect will decrease because more of the light that reaches the Earth will be reflected. If the albedo decreases, the greenhouse effect will increase because less of the light is reflected. If the greenhouse effect increases, then the temperature on the Earth will also increase. And if the temperature increases, the melting of the ice will also increase. So all these causal relations together form a positive feedback loop. And this is because there are two negative causal relations and the rest are positive. So the net result is positive. This means that the process of melting strengthens itself. So now let's look at negative feedback loops. A negative feedback loop weakens the change that was caused by a process. The causal relations in such a loop have a net negative effect. For example, if there is a positive influence from quantity 1 to quantity 2 and there is a negative proportionality from quantity 2 back to quantity 1, this is a negative feedback loop because the net result is negative. In the second example, there's a negative influence from quantity 1 to quantity 2 and a positive proportionality from quantity 2 to quantity 1. Again, the net result is negative, so it's a negative feedback loop. And in the last example, there's a negative influence from quantity 1 to quantity 2, a negative proportionality from quantity 2 to quantity 3, and a negative proportionality from quantity 3 back to quantity 1. Again, the net result is negative. Let's take the first example to see that a negative feedback loop weakens the change that is caused by the process. If quantity 1 is above 0, then quantity 2 will increase. And because quantity 2 increases, the change will propagate in reverse back to quantity 1. Therefore, quantity 1 will decrease. And because quantity 1 is above 0, it will go towards 0. That is, the negative feedback loop weakens the change that was caused by the process. Let's look again at a number of examples. This first example we've already seen in the model about carbon emissions. The process in the feedback loop is the photosynthesis of the plant population, which absorbs atmospheric carbon dioxide. So there's a negative influence from the photosynthesis to the amount of atmospheric carbon dioxide and a positive proportionality back to the photosynthesis. Because if there is photosynthesis, that is, it has a value above 0, the amount of atmospheric carbon dioxide will decrease. And the positive proportionality is true because if the amount of atmospheric carbon dioxide increases, there will be more carbon dioxide that the plants can use for photosynthesis. Because there is only one negative causal relation, this is a negative feedback loop. Therefore, the photosynthesis process weakens itself through this loop. The second example of a negative feedback loop we've seen in the video about equilibrium seeking mechanisms. This equilibrium seeking mechanism represents the flow of atmospheric carbon dioxide into the sea. So there's a flow which reduces the concentration of atmospheric carbon dioxide and increases the concentration of carbon dioxide in the sea. There are proportionalities back from the concentration to the flow. So on the left-hand side, we have a negative influence from the flow to the concentration and a positive proportionality back to the flow. This positive proportionality is true because if the concentration of atmospheric carbon dioxide goes up, then the difference between the concentration of atmospheric carbon dioxide and the concentration of carbon dioxide dissolved in the sea becomes larger. Therefore, the flow will be larger. On the right-hand side, there's a negative proportionality from the concentration back to the flow. And this negative proportionality is true because if the concentration of carbon dioxide dissolved in the sea becomes larger, the difference between the atmospheric carbon dioxide and the concentration of carbon dioxide dissolved in the sea becomes smaller, and therefore the flow is smaller. Because there is a positive influence from the flow to the concentration and a negative proportionality back, there's only one negative causal relation. Therefore, this is a negative feedback loop. These two negative feedback loops make sure that the flow always goes to 0, thereby weakening this process. Feedback loops can be further categorized into direct and indirect feedback loops. In a direct feedback loop, a proportionality immediately feeds back into the influencing quantity. For example, there's a positive influence from the natality to the size, and there's immediately a positive proportionality from size back to the natality. In indirect feedback loops, the change feeds back into the influencing quantity only after multiple proportionalities. So we've seen this in an example. There's a negative influence from the melting to the cover of the ice. There's a positive proportionality from the cover to the albedo of the Earth. There's a negative proportionality from the albedo of the Earth to the greenhouse effect. And there's a positive proportionality from the greenhouse effect to the temperature. And finally, there's a positive proportionality from the temperature back to the original melting quantity. So this is an indirect feedback loop. So, to conclude, feedback loops are essential to explain the behavior of systems. In a positive feedback loop, the change caused by a process strengthens this process, and in a negative feedback loop, the change caused by a process weakens this process. DynaLearn enables you to model these feedback loops using causal relations.